All right, guys, for the Explore station today, we have a demonstration to model plate tectonics and plate boundaries and what's occurring at each. Okay, so this paper right here is going to represent our lithosphere, which is broken up into our tectonic plates. Okay, so we can see we have arrows that are showing the plate movement. Okay, so for our first, we're going to look at slit B first. Okay, at slit B, we can see that our plates are moving apart. So what type of boundary would this be if the plates are moving apart? Okay, so we should have said that this would be a divergent boundary because they're moving apart. Okay, and the Atlantic Ocean is labeled here because the Atlantic Ocean has a lot of plates that are diverging or moving apart. Okay, so when the plates move apart at this divergent boundary or at slit B, I'm going to have magma coming up from below the lithosphere or from the asthenosphere. So as the plates move apart, okay, the magma is going to come up and it's going to cool and harden. So this blue strip is going to represent the new crust that's being formed as the magma comes up and cools and hardens. Okay, as the plates continue to move apart, more and more magma is going to come up. And so the older seafloor is going to get pushed farther and farther out from the boundary. So right now we can see my blue seafloor, which is older, is pushed farther out, while my newer seafloor is at the divergent boundary. And these can build up to create mid-ocean ridges, or we have rift valleys right here where they are moving apart. Okay, and because we have new crust being formed at these diverging plates and our seafloor spreading out, this is going to cause the Atlantic Ocean and areas that have diverging plates to become bigger. So our Atlantic Ocean is actually getting bigger every year because it has more diverging plates and new crust is being formed. Okay, so now, so we can see our yellow now is our youngest, whereas our blue is the oldest. Okay, so eventually our blue plates may meet another plate. So we can see here at slit C or at slit A. So we'll just focus on slit C. Okay, so as our plate comes together with another plate, so this may be another oceanic plate, or it could be a continental plate. My plate, the older plate or the oceanic plate, because it's more dense, is going to sink under. So as they come together, it's going to sink under and go back down into the asthenosphere, becoming magma again. So what type of boundary would this be? Okay, so we should have said that this would be a convergent subduction boundary, because convergent, they're coming together, subduction, it's going under. And at these types of boundaries, as it plunges down, we're going to get trenches right here where one plate is being subducted. And then near those trenches, we're also going to get a lot of volcanoes, which is like the Ring of Fire. So the Ring of Fire is in the Pacific Ocean. Okay, and what do you guys think is happening to the size of the Pacific Ocean if a lot of our crust is being destroyed or being recycled back down into the asthenosphere, becoming magma again? Okay, we should have responded that our Pacific Ocean is actually getting smaller each year. Okay, so while our entire Earth isn't changing in size, because while we have new crust being formed here, we have older crust being destroyed or being recycled back into the asthenosphere. So this is all part of the rock cycle. Okay,